So let us continue again with residues. Last time we have seen that by Cauchy's residue theorem, we get integration over C f of z dz equal to 2 pi I times summation of residues of f of z at z equal to zk, provided zk are the points where the function is not analytic and these are finite in number. So let us continue with few problems based on Cauchy's residue theorem. So I would like to deal with the first question number 2, first bit. Question 2 says use Cauchy's residue theorem to evaluate the integral of each of these functions around the circle mod z equal to 3 in the positive sense. The first function is exponential of minus z upon z square. You can say this is my function, exponential of minus z upon z square. Now, in this function, what you observe, the denominator is z square and denominator being z square, where it becomes 0 at z equal to 0, z square becomes 0, and you can watch over here. This is your organ plane. In the organ plane, we have circle centered at the origin with radius mod of z equal to 3, we are saying. Now we are worried about the point z equal to 0 as you are watching. This point, and you can see this point lies inside the circle. It is the interior point of the circle where my function fails to be analytic. So I'll use Cauchy's residue theorem. By that theorem, this integration will be equal to what? 2 pi I times residue of the function at z equal to 0, because at z equal to 0 my function is not, I mean f of z is not analytic. So this particular is my f of z. Alright. What I'll do is I'll expand the numerator using Maclaurin series. In case of Maclaurin series, all of you know that exponential of z is 1 plus z square by 2 factorial plus z cube by 3 factorial plus and so on. Let us use the same for minus z. So what it will be? 1 plus minus z. So it becomes 1 minus z plus minus z bracket square upon 2 factorial. So you got plus z square by 2 factorial. So wherever there is z, you are putting minus z here. So ultimately what do we get? Exponential of minus z equal to 1 minus z plus z square by 2 factorial minus z cube by 3 factorial plus z raised to 4 upon 4 factorial minus and so on. Do you agree? Do you agree? Any doubt here? Okay. So I suppose you are following the series of exponential of minus z. Okay. Now you want upon z square. So let us divide throughout by z square. If I divide by z square, I get 1 upon z square minus 1 by z plus 1 upon 2 factorial, because z square is cancelled over here. Then 1z is left over here. So it is minus z upon 3 factorial plus z square upon 4 factorial minus and so on. Do you agree? I repeat, we divided throughout by z square. term wise we divided by z square. First term becomes 1 upon z square. Second term was minus z. So minus z upon z square gives us minus 1 by z. Then you go for z square upon z square getting cancelled and you are left with only the constant term 1 upon 2 factorial. Then here it is z cube. So z square gets cancelled and I am just left with minus z upon 3 factorial plus 1 z square is getting cancelled and I am left with z square upon 4 factorial minus and so on. Followed? Okay. All right. So term wise we have just divided by z square. Now all of us know what is the residue. Residue is the coefficient of 1 upon z. So what is the coefficient of 1 upon z? You observe over here. This term is important to us. Coefficient of 1 by z is simply minus 1. So residue at z equal to 0 is minus 1. And you just put it back inside this formula. What is the answer? Minus 2 pi I. I suppose you followed me. Got it?
Yes, ma'am.
Yeah. So every time what do? We try to find out the coefficient of 1 upon z minus z naught. We always try for the coefficient of 1 upon z minus z naught. In this present case, z naught was origin. So we have taken 1 by z only. So I suppose you followed this. Now I would like to move ahead with the second question, second part of this. And it was, I think, you can read over here. This is z minus 1 bracket is square in the denominator. So let me continue. This is z minus 1 bracket is square in the denominator and dz. Again, what is your c? C is mod z equal to 3. This being mod z equal to 3, you can check if you deal with circle of radius 3, the point 1 lies over here. Point 1 is the interior point. So at z equal to 1, the function is not analytic. I suppose you are getting me. The function is not analytic at z equal to 1. So what do? I expand. So exponential of minus z you have. But I'm interested in getting z minus 1. So I have to add and subtract 1. So I say this is exponential of, I say minus in bracket. Let me subtract 1 and add 1. So what do I get? What do I get? Come on. This is exponential. In bracket, this plus 1 will come out with minus sign. So I got minus 1 minus bracket z minus 1. I suppose you followed me. Sure? Now, okay. So what to do next? I need to expand this. So this is e raised to sort of thing. So I can have e raised to minus 1 into e raised to minus of z minus 1. So e raised to minus 1 will stand outside by 1 by e. Now in the bracket, I have just to expand this. What is our expansion? 1 plus z. So my z is what now? Minus of z minus 1. Followed? Then I'll have plus z square by 2 factorial. So square of minus is plus again. So I'll write it as bracket z minus 1 bracket square upon 2 factorial. So what you understood out of this? If the power is odd, it will have minus sign out. If the power is even, it will be plus. So I'll have z minus 1 cube. And upon I'll have 3 factorial plus z minus 1 bracket raised to 4 upon 4 factorial minus and so on. Is it fine? Now we have to go with our function. What is our function given to us? Upon z minus 1 bracket square we have. So let us go to our function back. You can see here this is z minus 1 bracket square in the denominator. So I would like to go with that. Yes. Therefore, f of z equal to exponential of minus z upon bracket z minus 1 bracket square. So what we are doing, we are just dividing by z minus 1 bracket square throughout. So this 1 by e will be out as it is. 1 by e is there in the bracket. What do I get? First term becomes 1 upon z minus 1 bracket square. Then I'll have minus 1 by z minus 1 only. Then I'll have plus z minus 1 upon 2 factorial minus this will be.
Ma'am, it will be only 1 upon 2.
Yes, you are right. You are right. So it will be 1 upon. That is what I was trying to see whether you are attentive or not. Yes. So this is minus z minus 1 and upon you'll have 3 factorial. And you can say plus and so on. Our interest lies in 1 upon z minus 1 as you know. Our interest is in this term. So the coefficient of this term is going to provide us with the residue. So what is the residue here? Residue where add z equal to 1 of what? F of z. So just tell me what is the coefficient? Yes, come on.
Minus 1.
No. What else?
Minus 1 by E.
Yes, it is minus 1 by 1 by is there. Okay. So residue is minus 1 by E and therefore what will be the integration then according to your formula? Integration over C f of z dz will be equal to 2 pi I times the residue. So what is it? Minus 2 pi I upon E. Minus 2 pi I upon E. Followed?
Yes, ma'am.
So you can check here. It is minus 2 pi I upon E. So would you solve this? Z square into exponential of 1 by Z then?
Yes.
Okay. So Z square into exponential of 1 by Z. So how would you deal with it? How would you deal with it? Shall I leave it to you? Yes, come up. Where it fails to be analytic.
At that point,
Which point? Which point?
where the function is not analytic.
Where? That is what I want. See, if at a glance you see the denominator, you tell us what is the point. As far as the z square was concerned in the denominator, you said it is z equal to 0. For z minus 1 bracket square, you said 1. So what about this particular? Can anybody tell me?
At 0,
Yes, of course, at 0. Why? Because it is exponential of 1 by z, and you know, at z equal to 0, this fails to be differentiable, and that is why at z equal to 0, we need to search. Okay. So, would you go for this? I think you can. Now, in the beginning, you told me that the answer of D is some 5 times pi I. Is it so, Uddha?
Yes, ma'am.
So, let us try for this. Okay. C part I have left to you. What you are going to do is, you know better, have to expand exponential of 1 by z, and to that you will throw out multiply by z square. And because we are searching residue at which point? You are searching residue at the point where it fails to be analytic, meaning at z equal to 0. Okay. So we'll try to find out the coefficient of 1 by z. Sure?
yes, ma'am.
Okay, so I would like to go with the last question. I mean, z plus 1 upon z square minus 2z. So once again, you can see it is z plus 1 upon z square minus 2z. And again, the circle is the same, centered at origin with radius 3, mod z equal to 3. Now you can go with your function f of z. How is your f of z? Numerator is z plus 1, no doubt. But the denominator is z in bracket z minus 2. Yes, it is z in bracket z minus 2. So what it indicates? What are the points? Z1 equal to 0, where the function will not be analytic, and at second point 2. At z equal to 2, again you'll have a problem. So what to do? Yes, can anybody guess? Come on. So you should work on this so that you have some kind of Maclaurin series over there. You know better. If at all your mod z less than 1 indicates 1 upon 1 plus z can be expanded, and 1 upon 1 minus z can be expanded. Is it so? So are you able to expand anyway? Or try to write this as
Ma'am, the
some.
bracket,
1 by 1 plus z, so I know. It's
Yes.
possible.
So you should try to write this as sum of two partial fractions upon z and upon z minus 2 kind of thing. Can you? You may write this as, or the other way is, you may write it as z minus 2, and because you have subtracted 2, you need to add 2. So this becomes plus 3. And upon you have z into z minus 2, that kind of thing. So what do you get out of this? If you split it up, z minus 2 gets cancelled and you got 1 by z. And in the next place, what you are going to get? 3 upon, no, it will not work. Is it so? It will be 3 upon the product only. Okay, okay. Try to split this as a sum of two partial fractions. So how would you go? Yes, come up. You may say A upon Z plus B upon Z minus 2. So what will happen then? A times Z minus 2 plus BZ will be equal to Z plus 1. You put Z equal to 0. By putting Z equal to 0, what do you get? Minus 2A equal to 1. Is it so? So value of A is what? Yes.
minus a half.
Yes, you can write this as minus half. And now go for the value of B. So putting Z equal to 2 now. Putting Z equal to 2, what do you get? First term gets 0. This is 2B and is equal to 2 plus 1. Is it so? So what is the value of B?
3
Got
by
it? Yes, this is 3 by 2. Now can you expand this anyway? So 1 by Z will stand as it is. You can't expand it. So minus half upon Z stands as it is. Talking of this particular, I have to take minus 2 common. So I'm writing this as minus half. Numerator 3 by 2 as it is. I didn't touch it. And this is going to be 1 minus Z by 2. Can I say so? Will it work? Will it work? Because what I want is, I want the coefficient of Z minus 2. So I should write it in terms of Z minus 2 only. Yes, can anybody help me? Yes, I have mistaken. I have mistaken. Can anybody help me? Yes, can anybody help me? What you'll do? Are you getting my point? Instead of Z, I want Z minus 2. So what should I do? I'll write this as 1 Z plus 1 as it is. This is 1 by Z times 1 Z plus 1 upon Z minus 2 is there. Am I correct? Have we done such kind of things? And I can write this further as what? 2 plus Z minus 2. Can I? And multiplied out by, here again I can adjust Z minus 2 plus 3 upon Z minus 2. This is quite possible. What next I can do? This is 2 plus Z minus 2. So let me take this 2 common. So what I'm left with? 2 is taken out. So it becomes half. This is 1 upon 1 plus Z minus 2 upon 2. Am I right? And multiplied by This z plus 2, let me bracket so that I can use it. Z minus 2 upon z minus 2 is going to give 1 plus this will be 3 upon z minus 2. Followed? Are you getting my point?
Yes, ma'am.
Okay. What next to do? So half as it is. You can expand this particular term. So in bracket, what is the expansion? 1 minus, because alternate plus minus sign we want. This is z minus 2 upon 2 plus z minus 2 upon 2 bracket square minus z minus 2 upon 2 bracket cube plus and so on, and multiplied here by 1 plus 3 upon z minus 2. Now you multiply them. If I multiply inside, what do I have? Half as it is in bracket. I'm multiplying by 1 throughout. So all the terms will remain as they are. So I have 1 minus z minus 2 by 2 plus z minus 2 bracket square minus z minus 2 by 2 bracket cube plus and so on. So if I multiply by 1, I get all those terms as they are. Now I'm multiplying by 3 upon z minus 2. So if I multiply to the positive one, it will remain positive, and to the negative one, it will remain negative. The sign here is plus. Keep this in mind. So this is 3 upon z minus 2. Now it is minus z minus 2 is going to get cancelled, and I'm just left with 3 by 2 times 1. Then this is plus, this is 3, and denominator is 4. So 3 by 4 times single z minus 2. What next? Minus, this is 2 cube, so 8. I'll get 3 by 8 and z minus 2 bracket square and so on. Followed this? Is this fine? Okay. Now I have just to collect the terms, but I'm not interested in. What I'm interested in, simply the coefficient of 1 upon z minus 2. And what is the coefficient of z minus 2? There is a single term with z minus 2 in the denominator, as you're watching. So its coefficient is 3 by 2. So residue of f of z at z equal to 2 is equal to 3 by 2. Same way I have to find it at z equal to 0 also. We tried it at z equal to 2. Now we have to go with z equal to 0. So did you get me? Any doubt here? This is at z equal to 2. So if you want the screenshot of this, I think I should reduce it. Yes, now you can take it. Okay, hope you are ready. Ready for the next part? Okay, okay. Now I want residue at z equal to 0. And for getting residue at z equal to 0, I'll take the help of this partial fractions. So as far as the partial fractions is concerned, what I can do is I can write the same f of z as minus half that you have already calculated upon z. And for this is 3 by 2 times plus 3 by 2 is there. And you are taking minus 2 common from the denominator. So multiplied by minus 2. It is taken common from the denominator and I'm getting this as 1 upon 1 minus z by 2. Am I correct? So you can watch it over here. Followed? Yes or no? See, once again, I would like to tell you, I just first dealt with z minus 2 and here now I am interested in z minus 0. For having z minus 0, what do? I want the terms strictly in terms of z. And for that, I'm trying to bring it in the format of 1 minus alpha. Sure? So what I have done, with the help of A and B, we have just now found out the values of A and B. A was minus half, B was 3 by 2. We have written this way. I suppose you followed. Are you getting where? So now let us expand it. So what do you get over here? 1 plus z by 2 plus z square by 4 plus and so on. Now this will be equal to minus 1 by 2z minus 3 by 4 minus 3z by 8 minus 3z square by 16 minus and so on. So the coefficient of z you can watch here. Therefore, I can say residue. Where we are finding the residue? At z equal to 0 of f of z. How much it is? It is minus half. Followed? It comes out to be minus half. See, in the bracket, if you see, the terms are all positive powered terms. So z appears in the numerator. The only term that has z in the denominator is minus 1 by 2z. This is the only term, and that is why its coefficient of 1 by z is minus half. I suppose you followed me. And now, so if you want screenshot of this, you can take. Ready for the next?
Yes, ma'am.
Okay. So what you can see here, then you have to go with the addition of the residues. So integration, what is our formula? Integration of f of z dz over c is summation of the residues multiplied by 2 pi I. So we have 2 pi I multiplying to the sum of, this is 3 by 2 and this is minus half. So what is the answer? Got it? We are adding the residues. So 3 by 2 and minus half. The addition is 1. So the answer is 2 pi I. Okay, so you can check here. The answer is 2 pi I. So what you need to do in such cases is, if you want residue at z equal to 2, you are searching for the coefficient of 1 upon z minus 2. If you want residue at 0, you are searching for the coefficient of 1 upon z minus 0. So always keep this in mind. That provides you residues. And then by Cauchy's formula, you just add the residues and multiply it by 2 pi I to get the integral. Followed?